Black math! Give me some math and I'll give you some flack. Black math!
All right, 74. We're going to find the discriminant. So this is an important word. You will have questions like this on standardized tests and stuff like that. I think I heard, what's the divergent series again? What happened?
Divergent.
No, just me.
It just went from Halloween to Christmas. Yeah.
Why all I want for is you? Why are they fun?
Oh,
What curriculum could this possibly be? Sorry.
Okay, so discriminant. So in the divergent series, I think there was something like there's a book that was written that wasn't. I think we already talked about this. Whatever. But there's like another book, but it was the same as like one of a mathy term. But anyway, divergent, and then what were the other two?
Insurgent.
No, insurgent, and then there's
those three. Allegiant.
Yeah, allegiant. Yeah, but then there's another one it's called discriminant or determinant. I think it's called this. I don't know. But anyway, we're going to talk about the discriminant. I'm just gonna jump in. Here we go. Okay, so the discriminant basically tells you what kind of solutions you're going to have. So if I look at the quad formula, quad form is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now, this plus or minus says that there's probably going to be two answers, right? But what if this is the square root of 0? What happens when you add 0 and subtract 0? Are you going to have two different answers? No. So we're going to say it. So this is called the discriminant. So this determines whether and what kind of solutions you're going to have. If discriminant equals 0, so basically if b squared minus 4ac equals 0, then you have one real solution. Because you can take the square root of 0. What's the square root of 0? 0. Okay, so if b squared minus 4ac is less than 0, well, what does that mean? You're going to have underneath the radical a negative number. And so you're going to have, and you're going to have two, but you're going to have two complex solutions. Now, I say complex because this part is still real, right? So you're going to have a real number plus or minus an imaginary number. That's a complex number. And you're going to have two because unless this is 0, which is not, it's a negative number, you're going to have plus that imaginary number minus that imaginary number, okay? Now, if b squared minus 4ac is greater than 0, then you have two real solutions. Okay, so this discriminates your solutions, okay? It tells you what kind of solutions you're going to have and basically how many. All right, so if that's 0, then you technically have one solution, but with a multiplicity of 2, right? That's when you have like x equals 4 in 4, like x minus 4 equals 0. So it's 4 in both of them, multiplicity of 0 or 2. Okay, so this is what these guys look like. So if you have x, you might have a situation like this. So this is where b squared minus 4ac is greater than 0. B squared minus 4ac is greater than 0. Then you might have a b squared minus 4ac equals 0. And then you might have something like this. This is a b squared minus 4ac is less. Ooh. Sorry. Okay, so that's what those graphs look like. You don't really need to know the graphs too much, but let's just try some examples. These are going to be real easy. Example 1, I want to use the discriminant to describe the roots of each equation. So we're going to describe the roots. Remember, the roots are just the solutions. Describe the roots of A is 4x squared plus 25 equals 20x. 4x squared plus 25 equals 20x. Okay, so what do we do? Rock, everybody just rock and roll. That's it. That's what we do. Okay, so what the heck is A, B, and C again?
A is 4.
B is, right, so remember, get that over there first. And so you get 4x squared minus 20x plus 25. So that means A is 4, B is negative 20, and C is 25. Now, you could put that into the quad formula and try to figure out what your solutions are. And then you can describe your solutions, no problem. But it doesn't say solve it. It just says describe your roots. It doesn't say give the roots. So what are your roots going to be? Well, let's pop it into our discriminant. What's our discriminant?
B squared minus 4.
All right, so this is all we have to do. We don't have to put it in the quad formula. We just have to do the discriminant. Okay, so that's negative 20 squared minus 4 times 4 times 25. Well, so that's 400 minus 400. So what kind of solutions are we going to have? One real solution. So one real solution. That's not bad, right? Okay. All right, what about this one? Let's do B here. 2x squared plus 7x minus 99. Right, it's already in standard form. So it gives us A, B, and C. So 7 squared minus 4 times a negative number times 2. 4AC. Now, why didn't I bother finishing this?
Because it's negative.
It's a positive minus a negative, so that's going to be a big positive number. So you can just say big number times 2. So it's basically a number plus a positive number plus a positive number. So it's going to be 2 real solutions. Yep. So it's nice because once you get to that part, and sometimes you can even look at it. Well, this is always going to be 2 real solutions. Always. Okay? Because it's going to be a positive number minus a negative product. So plus another positive number. So anytime you have positive A, positive B, and a negative C, it's going to be 2 real solutions. Okay? All right. What about this? Oh, it's not it, but it's not going to be much today because we're only doing one lesson.
Oh, thank God, because my brain cannot handle it.
3x squared plus 6x plus 5. 3x squared plus 6x plus 5. Can you do this one in your head? Is it one real, two complex, or two real?
It's too real.
Okay, let's see. So b squared minus 4ac, right? So 36 minus 4 times 3 times 5. This is negative, right?
Yeah, it is.
So 2 complex. Okay, so if you end up with a negative number, after you pop it into b squared minus 4ac, it's 2 complex numbers. If you end up with a positive number, it's 2 real. If you end up with 0, then it's 1 real solution. Okay? Now, this also tells you whether you're going to have rational solutions. Like if you end up with a perfect square, if b squared minus 4ac is a perfect square, then you're going to have a nice rational solution because you can take the square root of that and then the radical goes bye-bye, right? And you're going to have either a fraction or a whole number as your answer. That's nice. Or not a whole number, but maybe an integer. Okay? But that's all we're doing now. The discriminant just says whether they're real or not and how many there are. Okay? Using a positive discriminant, like you can do this on a calculator if you want, but example 2 says this. I'm just going to read this to you. We aren't going to do it, but I'm going to read it to you. So a player standing on a 10-foot hill kicks a ball straight up at a velocity of 55 feet per second.
Yeah.
Okay? So he's standing on a hill and he kicks the ball 50 feet above the ground. Oh, he hopes it will go above the roof of a nearby building, which is 50 feet above the ground. Okay, so he's already on a 10-foot hill. The function that gives the height of the ball after x seconds is given by y equals negative 16 x squared plus 55x plus 10. So that's not important. It's just like a physics equation, whatever. Okay? But use the discriminant to explain why the ball will reach the desired height. Well, the discriminant is basically, the discriminant is 465. Okay? That's the discriminant. So what does that tell you? Positive 465 is the discriminant. What does that tell you?
2 real numbers.
So you're going to have 2 real solutions. So since the discriminant is positive, then there are 2 real solutions, indicating that the ball has a height of 50 feet twice. So the solutions give the number of seconds at which the height is 50 feet. So that kind of makes sense because it's 50 feet here, and then when it comes back down, it's another 50 feet, right? So at a 0 height, because remember, he's 10 feet above, well, no, he's not, on the building, so reaching the building. Okay, so using a 0 discriminant. Here's another one, ready? And you're going to get some of these in your homework. That's why I'm reading them to you so you kind of know how to prepare for it, but really, it's just an excuse to find the determinant, okay? A homeowner has 120 feet of fencing material to enclose a rectangular dog pen, okay? Can you visualize it? She wants the dog to have 900 square feet of space inside of the pen. The equation W times 60 minus W, basically area equals length times width, equals 900, gives the width of a pen that meets these requirements. Use the discriminant to explain why these requirements can be met. Well, if you simplify that, W times 60 minus W, it's just 60W minus W squared equals 900. Okay? So that's a quadratic equation, right? So B would be negative 60. C would be negative or positive 900, and A would be 1. Okay, so if I put the negative W squared over there. So the discriminant basically is 0. Okay, so the discriminant is 0, so there's only going to be one solution. Since the discriminant is 0, there's one real solution, indicating that there exists one width which meets the requirements. The solution gives this width. Okay. So when you find the solution, that is the actual width. But All right, so it's different because there can only be one answer. You better have a zero discriminant. Okay, now here's where it gets interesting. Using a negative discriminant. When is that ever going to be useful? Well, listen to this. So a frame maker, so a picture frame maker, has 50 inches of framing material with which to make a picture frame. He wants to frame a picture that has an area of 160 square inches. Okay? The equation, same thing, W times 25 minus W equals 160 gives the width of the frame, just like we did with the fence. All right, use the discriminant to explain why these requirements cannot be met. Well, if you have a negative discriminant, then you don't have a real solution. And this guy lives in the real world. So when it comes to actual physical dimensions, negative or imaginary numbers don't make sense. Okay? So he can't do it, unfortunately. He needs to quit his job. All right. That's it.
Black math, give me some math and I'll give you some flack. Black math.